Hello, welcome back to the channel. So let's continue our indefinite integral questions again and solve this type of question. And before we solve this question, I would highly suggest you to first watch the previous videos in order to get the complete idea about what we are doing in this video in order to solve our indefinite integrals and what tips and tricks we are using in order to simplify our indefinite integrals into the best form so that it's easier to calculate, so that we have the best form for calculating that indefinite integral. So now let's start with finding the integral for tan square x dx, and now the first thing is again to identify the pattern and see what we can do with tan square x and convert it to something to what we already know the indefinite integral for. So in this question, and by looking at the chart, we notice one thing, that there is nothing much we can do with tan square x, but there is definitely something we can do with secant square x, and we know a relation between secant square x and tan square x, right? And the relation is tan square x is equal to secant square x minus 1, right? This is the property that we already covered in our previous classes, right? So we will use this property and we'll convert our tan square x, and because I already know an indefinite integral for secant square x and I already know an indefinite integral for minus 1 as well, it would be much easier for me to evaluate this expression, the indefinite integral of this expression, rather than this expression. So now let's start converting our indefinite integral into the best form possible. So the original question is to calculate the indefinite integral of tan square x. Based on the conversion, we know that tan square x is equal to secant square x minus 1 dx. And I know from the properties of indefinite integrals that I can split both of those functions and add the indefinite integral to both of them, right? So this becomes secant square x dx minus 1 dx, right? And now based on the chart, I know that the indefinite integral of secant square x is tan x, and the indefinite integral for 1, as we already know, is x. So this becomes tan x plus, let's suppose c1 is the constant of integration for our first expression, and for the second expression it would be minus x plus, let's suppose c2 is the constant of integration for our second expression. So now by simplifying it down, it would become tan x minus x plus c1 minus c2, right? And I can just convert this c1 minus c2 to just c. So tan x, the final answer would be tan x minus x plus c. And the reason why we did that is to simplify our constant of integration, because we don't want many constants of integration in our expression. So it's recommended to have only one constant of integration, because this and this is also a constant, right? So it completely doesn't matter if you have two constant of integration or one constant of integration, the answer is always the same. But generally, in order to answer the indefinite integrals, we write only one constant of integration, because having more than one constant of integration is just redundant. So that is why this was an important point to cover, that it doesn't matter if you are evaluating those expressions separately and then adding those individual constants of integration, or what you can do is you can evaluate the integral of this, the integral of this one, which is tan x, the integral of this one, which is x, write the final answer without the constant of integration, and then when you reach the end, just add one constant of integration, and that would also be your correct answer. So that is why it doesn't matter if you use more than one constant of integration or just one constant of integration. Both of these approaches are exactly the same. So that is it for this video. In this video, we covered the conversion of indefinite integrals into the best form possible, so that you can evaluate the indefinite integral for your best form very easily. Feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.